What's another one we did? Cosine. So y equals inverse of cosine of x. What is its domain of this function? Look back up if you don't remember. What is its domain? I heard -1.
Well, I don't think I'm right.
I think you are. -1 to 1. Yep. Okay. Yeah, they did switch.
Oh,
Remember, our domain was all wheels. Yeah. Looking at inverse functions. So we're looking at this one right now. Oh, we didn't even write the domain. So domain was that. What was the range of that function? Yep. 0 to pi. What quadrants is 0 to pi? If I start at 0 and I go all the way to pi, which quadrants? 1 and 2. Yep. So quadrant 1 and quadrant 2. Those are the only two ones. Landon, what's my last one? What's my last function?
last one is sin.
Sine.
Sine.
Yep. And we're doing the regular one or the inverse of it? Inverse. So inverse of sine of x. What was the domain? Yep. -1 to 1. Angel, what was its range? There's a seat in between Kennedy and Lily, too, if someone over there wants to move. Yeah. We guys can scooch, too. -pi halves. Can't see what? Oh. What quadrants are you in? Yep. Quadrant 1 and quadrant 4. Okay, this is the only thing you have to remember from yesterday. The domain and range restrictions for the inverse of all these. Yes. Why is this important? Okay, okay. 0. 0 to pi. Okay. We're going to do an example. Problem. Yeah. What have you been doing? Oh, Brent, go ahead. I want you to find what is sine inverse of 1/2. I'm not even going to tell you what it even means yet. Yep. Sine inverse of 1/2. The inverse of sine of 1/2. How many radians am I at? Brent, I'm going to move it down. I'm sorry. Okay. Simple. Find what is the sine inverse of 1/2. Don't just copy, King. Talk about it. Okay, remember when we did... Okay, remember when we were graphing? Amy, remember when we were graphing and we were making tables? And you had a value, something like this. Do you know what that means? How do you say this in words? Yeah, so what is sine at pi halves? So that means we're looking at the y value at pi halves. So everyone, look at the y value at pi halves. What is the y value at pi halves? Yeah. So it equals 1. This is the opposite. This is saying, what is the radians when sine is 1/2? So now I have to look on a unit circle, see where sine is 1/2 in all my coordinates, so when the y value is 1/2, what radians am I at? So what radians are we at? Grab your unit circle. Well, good thing you memorized it. Opposite the unicycle, who wants one? No, you all have them. Okay, that's fine.
Oh, yo, that's okay.
Look on unicycle. Where is sine 1/2 in the coordinates? What radians or degrees are we at? Look at unicycle.
Check it. No,
Sine is the y.
Sine is the y.
For
It's the y coordinate. You gotta tell me a radian or degrees. Pi 6? Okay, pi 6 and 60 degrees are two different ones. Okay, pi thirds. Where else? There's two solutions to this. We said pi thirds, no,
wait, how did we
pi 6. Same as 30 degrees. Look on a unicycle. Okay.
now what?
Who has the unicycle? Hold them up.
Oh, 1/2.
Okay, look at this.
Oh,
I'm looking at all of the y values right now. Because we're looking at sine. I said that when I was out. Where is this x value 1/2? Okay. Y value, sorry. Y value 1/2. 30 degrees? Okay. There's another solution to this.
5/6.
Yes. Do we see it? 5 pi 6. If we're in the second quadrant, sine is also positive. So we don't want the negative 1/2. Don't want them. So we're in quadrant 1 and quadrant 2. So we're at 30 degrees or 150 degrees. So, or 5 pi 6, which is also 150 degrees. So this is in quadrant 1. This is in quadrant 2. One of these actually can't be the solution because there's restriction with the inverse of sine. Which one do we cross out? Thank you. Okay, look at the domain and the range of the inverse of sine. We said it could only be in what two quadrants? 1 and 4.
1/1.
Yes, so this one is fine. We're in quadrant 1. Quadrant 2 does not work. Sure, you can call it extraneous. It's just not a solution. So an extra solution, sure. So it's extraneous. This is the only solution we have. So not a solution. Okay. Questions? Or are we going to do this up on the board? Are you listening? Kennedy. Okay. Boards. Do we... Okay. Look at the notes. Okay. Because the inverse of sine has a restriction. It can only be in quadrant 1 and quadrant 4. The 105, 150 is in quadrant 2. So it's not a solution. It's extraneous. We can use that word since we're so used to it. It's an extra solution. It's extraneous. You ready, Sunny? For boards? Okay. I didn't pick board groups. But I'm just going to pick a random day where I did pick board groups. And we're going to go with those board groups. Okay, I'm switching it up. This is geometry. Let's go to algebra. Let's go to chapter 5. No, this is when we start sharing a folder. Yeah, well, that's going to be on your, final. So, oh, 6.6 groups. Okay. Those are your groups. Go out, find a board. I'm going to give you 2 problems to do.
I was right here. Yeah. Oh wait, 6 on right there.
Okay. We got our groups. I'm making it small. Okay. Gotcha. You want a third one, Naomi? I'll give you a third.
Oh,
Just for you. Just for you, Naomi. Mm-mm.
So what's the
210 and quadrant 2.
So quadrant 2 and 3. Yeah. What's it supposed to be?
Okay, first one. Ooh. Not that. What was the answer to the first one? Yep, 5 pi 6. 150 degrees. Second one. Nothing. What was the solution that I did not take? Yep, so this is quadrant 4. Quadrant 2. Should have been the other one. So 2 pi thirds was not the good one. Okay, last one. We should have been in quadrant, maybe quadrant 1 or quadrant 2. Which ones are we in? It's not quadrant 2. It's quadrant 4 with sine. We're looking at sine. I'm scooching down. Wait, I'll go back. Quadrant 2 is a no. Sine should be quadrant 1 and quadrant 4. Yeah, okay. So I can't do quadrant 2. Where were we in quadrant 1? Yes, 45 degrees. Or the same as pi fourths. What? What's up, Michael? Either one is fine. I would take either one for these problems. Okay, that's evaluating inverse trig. Evaluating just what these mean and what they are. Okay. Next. Scooching down. Should I do this one? Sure. Find all values. What's up, Sunny? Find all values. We'll put in degrees for today. In degrees. Whom sine is 0.95. This is still 8.1. Yep, it's a long one. We'll see if we get to homework. So right now, we need to find the angle. We know what sine is, so find angle. Right now, we know that 0.95 equals sine of something. How do I find the angle, which is theta? What do I have to do? Yep, inverse of sine. So, take inverse on both sides. So, inverse of 0.95 of sine. So, put on both sides. Sebastian, what happens to the right side of this equation? Yep, the signs cancel out. So we have sine inverse of 0.95 equals theta. How do I find that value? Plug it into what, Lily? Calculator. So everyone grab calculator. You whispered it.
No, go back. Please.
So, Betty.
Circle on all those papers. No, like the one I did.
There's Lily's.
Yeah, that was
Lily, you just share everything with them.
1.25.
Yay.
It doesn't even matter if you're doing
1.25.
Yeah, yeah. Okay. On here, put it into degrees. We're gonna deal with radians in a minute. But for right now, go to degrees. Go to mode, right on the top. And it should be like blinking for the degree. If it's blinking for radians, then just go over to degrees and hit enter. Okay. How do I get inverse of sine, which is right there? Yep. Do we all do second sine to get inverse of sine?
You don't have to finish the method.
No, you don't. No, not if you don't. You're not scribbling it or anything. So we got an answer, 71.80. Right? Okay, that's actually not only solution. Your calculators are super dumb, and they only give you one solution. There are two solutions to this problem. We're gonna have to keep doing this over and over again. There's actually probably gonna be multiple solutions to multiple problems, but we have one solution to this problem. So let's draw this out. You have your x-y axis on a unit circle. We went from here and we went up about 71 degrees. So which quadrant should I stop in? 1. That right there. Okay, remember our lovely acronym for when to tell things are positive or negative? What is it? See, wait, let me pause. Okay, all students take calculus. So we're in quadrant 1. Where else is sine? Oh, I see. Where else is sine positive in? A is for all positive. S is for sine is positive. T is for tangent's positive. Cosine, C is for cosine's positive. So where else? You know why? Because you guys went here and you should have came in and learned it or watched the videos. Okay, everything else is negative. If it's not these letters, it's negative. So Sebastian, where else is sine positive in? 1 and 2, perfect. So it's also, there's a solution right there. Your calculator is not giving you that solution. They're giving you the easy first solution. They're giving you the 71 degrees, not the other one. But we're smarter than calculators, right? How would I get the other solution? Yes, so true. Okay, it's a reflection right across the y-axis. So this line just reflect it right over the y-axis, right over there. So for cosine, yeah. So I'm at 0. I'm at pi over here. This is sine, so I said. No, okay, only for sine is an odd function, so we reflect over the y-axis. I mean, no, because it's some from 0.95. Yeah. Okay, how do I find it? Remember bow ties and butterflies? Okay, this is the bow ties and butterflies. This angle right here is supposed to be the same, right, as that one? Yep, it's going to be the same. So if we're at pi here, I should do pi minus theta to get that new angle right there. So, yes. Wait, let me draw it better. Right there. This angle that goes from here to here, from our initial to our terminal, is pi minus theta. That's how we get it. So just do pi minus theta for sine. What? No, it's... So we went all the way pi, and we want to go minus how many degrees we went. So I'm going a full 180 minus the 71, so I get to where this line is. Yeah. Because it's a nice half of a circle. So where am I at over here? Lily should be negative. No, I'm going, I just want to see what this is. I want this angle. Pi minus, yeah, pi is 180. So do 180 minus our 71, what? 109. So this should be 109 degrees. Cool? Yeah? Guess what? There's different symmetry for each one. This is symmetry for sine. Okay? Scooching it down a little bit. I hope we got all those notes. So symmetry for each trig function. Okay, we have done next page. Y equals sine, oh, we'll just do sine, y equals sine of x. We had symmetry over what axis? Over y axis. And to get our new point, we had pi minus theta. Symmetry. Yes. So if I have this point, the new point is also over there. So this angle, if this is theta, sorry, it's written really fat. Theta, this is pi minus theta. That is sine. Where is cosine positive? What quadrants? Yep, cosine. 1 and 4. Yes. Do we all get that pretty fast now? Thumbs up if you get what quadrant I'm talking about really fast. Thumbs down if you don't. Okay. Okay. Scooching down. We have y equals cosine of x. So we're looking at all students take calculus. Angel, what does A stand for? All positive. Which one is cosine positive of the other three? 4. Boom. So we are in 1 and 4. So if I get my initial one up here, it's going to reflect over the x-axis and be down here as such. So this is my theta. This is going to be negative theta. Okay, so symmetry over what axis, Mark? X. Yep, x-axis. And you can say negative theta, or you can do a whole 2 pi minus theta. Whatever one you want. I think just put a negative, it's probably a whole lot faster. Yes. Lovely. That's the next one. Landon, you got that so fast. We're going to go for tangent. Y equals tangent of x. I'll slow down. You write. I'll pause. We're trying to figure out where it's going to be positive. Sine, cosine, and tangent. We've already done this. We're just now taking a side, and we can flip it. So if I'm at like 30 degrees of cosine, I'm also at negative 30 degrees. The cosine is both positive in both of those. So they have the same x value. That's what it's just saying. Okay. We'll do examples. Okay, tangent. Landon, why is it quadrant 1 and quadrant 3? Yeah. Can someone go shut the door? Thanks, buddy. Natalia, Did you hear what Freddie said? Okay, Freddie. One, not Freddie. Sorry. Did you hear what Landon said? Landon, say it one more time. Okay, so that's why we're going to be in quadrant 1, but also in quadrant 3 for tangent. So remember the whole bow ties and butterflies? Is theta going to be on side 1 or side 2? 2. On the second side. This is where theta is. This is 0. This is pi. So Angel, I'm going to take theta. I went all the way pi, and I'm going that same additional theta. So yes, I'm going to go theta plus pi to get the other point. So symmetry over origin, and we're doing theta plus pi. Say it again.
It's pi 180 situation sine and tangent.
If you change pi into degrees, what do you get? Yeah, so always 180. Pi is always 180 degrees. Cool. Let's do a problem. It's going to be hard. Because we're going to apply it. What? You want a hard problem because you're all bored. We're going to solve a trig equation. I would love to do that. Solve a trig equation. If we get 2 of them, we can have a windbreak. Yeah. Solve trig equations. 1. We're going to do 6 sine theta equals 3 sine theta plus 2. Plus 2. I need to solve for theta. So kind of like above, when we did up here, we found an angle. We want to solve this equation. Yep. Subtract what? Yes, because they have the same argument. It's just theta and theta, which we're going to have in practically every problem. So minus 3 sine of theta minus 3 sine of theta. If you don't like seeing sine of theta, you can replace sine of theta for a moment with just x. So if you want to do like sine of theta equals x, it just changes this problem to 6x equals 3x plus 2. Okay, you can do that too. And we do minus 3x, and then we get 3x equals 2. Okay, okay.
You divide by the sine of theta. So it by itself. So
We can do that. Yep. Let's do this. This is 3 sine of theta equals 2. So divide by 3. Divide by 3. Kenny, I get sine of theta equals 2/3. What do I have to do next? So I'm going to scooch it up because I ran out of room. How do I get theta all by itself? Yes, but I want Kenny to say it. Amy, what do I have to do? How do I get theta all by itself? We can't divide by sine, but we can take something from both sides. How do I get rid of a sine? Yeah, use the inverse. So take the inverse of both sides of this. So sine inverse, and then sine inverse. I wrote that weird, but yeah. We get theta on one side, and we get sine inverse of 2/3. What's up, Michael?
what if you did sine inverse of 2 over?
No. Because then the 3 is like inside, then it's not the inverse of a... That's not the same thing. It's not like sine and sine. Yeah. Move the 3 first. Okay, calculators. What's theta? Yeah. Okay, we're gonna have to go into radians later. We're gonna do that on Monday because it's a little confusing. So theta was what? 41.81. You guys are so quiet. But that's only one solution. What's my other solution? So Mark, we're gonna do pi minus theta because it's sine and reflecting over the y-axis. So what is pi minus our theta? So take the 41.81 and I'm subtracting it from what? 180. Yes. 138, probably point something. 19 degrees. These are my 2 solutions. Yeah, I gotta tell you, right now you are all doing pre-calc. Yep, they just put these into radians. But it's very similar to pre-calc, the equations just get a lot uglier. Yeah, so who's taking pre-calc next year? Welcome to your future. The symmetry above is for polar coordinates, which is also your future. Okay, let's do another. And I've also ran out of more room on this page. Okay. Brain break once we do one more. You do know what's going on, Kennedy. What?
What? We don't have to quadrant.
Well, we know already because it's signed that's going to be quadrant 1 and quadrant 2. So these are going to be the 2 solutions. Yep. Okay. Example. Let's do 0.25 cosine of theta plus 1 equals 1.5 cosine of theta. So solve it for all values.
That's not my fault. They just did the license.
I got 36.87 and 323.
Wait, Ronaldo, what quadrant is cosine?
Cosine? Like positive? 1 and 4.
Okay.
Wait, but I still got the right answer. Wait, what
Oh, wait.
was no, we subtracted
36.87.
36.87.
I'm going to erase some stuff so we can keep going with this one.
But then
Oh.
Okay, I have my function. Ooh. Yeah. Okay. If you hit math, I give you options. So you want decimal, right? So I go forward down decimal. Yeah. Okay, 0.25 cosine of theta plus 1 equals 1.5 cosine of theta. We need to combine like terms. What are two like terms? Yep. So subtract 0.25 cosine of theta minus 0.25 cosine of theta. Get 1 equals 1.25 cosine of theta. I need to divide. What am I dividing by next? Yep. 1.25. 1.25. 1 over 1.25 equals cosine of theta. Brent, what should I do next to get theta all by itself? Thank you, Brent. No, Brent. What do I have to do to both sides? So I get theta all by itself. Look above in the other one. Oh, I erased it, that's why. Sebastian, help out Brent. Yeah, I want to take the inverse of cosine from both sides. So inverse of cosine, ooh, right there, equals, if I take the inverse of this, I'm just left with theta. So theta. So what is the inverse of cosine of 1 over 1.25? 36.7 degrees, 87. I'll just put 8 for now. Equals theta. If you got 0 point something, that's because it's in radians on calculator. So 0.6 or something. Okay, we're in quadrant what? 1, 1, and we want to get to quadrant 4. How do I get to quadrant 4? Yep, that's really fine. You can add negative. So we have 36.8 and negative 36.8. You can just add the negative because it's down. But how do I make it positive? Yep. Which would be what? 306.9. I would take either one of those answers.
I can just say negative.
Yeah. Is that what you get when you start 360?
Because it's 2 pi minus 6.8, right? So that's why you get negative.
360 minus 36.8. Yeah, you want. Yeah, it's 32. 332.2 degrees. These are the solutions to either of the problems.
You like got it wrong.
It's, yeah, I got it right. What?
This is 23.7.
Look, 2 pi minus theta. 2 pi is 360. 360 minus.
Wait, but we do have time for homework.
No.
No one said that.
Hey, no one said that.
We do have time for homework.
Let's play the bus game. Please, I like the bus game.
Okay. We'll do it at the same time.
I don't play this game anymore. Excuse the homework.
Okay. I gotta find it though. I didn't pick it out yet.
Maybe it's a sign.
I'll give it a short one. It'd be half your homework.
I don't think we should.
9 through 57.
3 questions.
I think we got it.
Yeah, I think we got this.
We'll see. We'll see. Okay, homework. Homework. 8.1 page. Let's do 4-1. It'll be short. Maybe. 4-1. Yep. Okay, 16. That's page 4-1. 16.
That's it.
I'm thinking. 20, 21, 24, and 26. That's 5 problems, and they're all really short. No, none of them are equations. Do you want one equation?
No, it's okay. Thanks for that, though.
Yeah. Oh, cool. Do you want me to fill this out now? Angel, do you want me to fill this out now? Okay. Bye. Oh, I should.